So we have Joeri Robbrecht from DG Environment, who is not yet a user of the vocabulary, but is dealing with criteria and evidences, and will talk a bit about requirements towards this kind of vocabulary from an environment perspective. Joeri, the floor is yours.
Thank you very much, Suzanne. Can you hear me?
Yes, perfect.
Okay, thank you. So thank you very much, and hello to everybody. I'm Joeri Robbrecht. I'm a policy analyst at DG Environment, Unit E4, Compliance and Better Regulation. And I'm mainly working on the Aspire Directive and the optimization of the reporting flows in the DG Environment. As the title of my presentation says, I will present an environmental use case for semantic interoperability, but actually I will present two use cases that both benefit not only from a semantic interoperability, but also from a legal interoperability. Now, for some background, typically for the environment is that we have no borders. The nature does not respect any virtual borders created by man. And most of our environmental phenomena, such as floods, eutrophication, acid rain, air pollution, climate change, plastics in the ocean, they have a cross-border aspect and they have an impact across the borders. As such, this use case presented is presented from a perspective at EU level, but it's only also valid at any level of governance, meaning nationally, regionally, locally. Cross-border collaboration in the environmental matters is essential. Some numbers: 20% of the EU citizens live within 50 kilometers of a border, and about 70% of all the freshwater resources we have are coming from cross-border boundary river basins. That means that collaboration and interoperability are key instruments to manage our national capital and to prevent disasters and mitigate the negative aspects or impacts of our consumption patterns. Next slide. And because of the cross-border nature of the environmental policy, most of the environmental legislation sits at EU level. If you look at the policy cycle, this is this one on the left, then you can see by default the environmental policy is evidence-based, and for every policy development we have to do an impact assessment. And that impact assessment has to look at the pressures, the state, the drivers, and the impact on the existing ecosystems, and has to formulate the most effective measurements for policy to address the negative impacts of the human activity. To do so, we need a lot of evidence, so the process is very data hungry, and we need a solid evidence base with high quality data. As the cycle continues, then we go into monitoring and reporting, and so the competent authorities on the member states, they have to report on the implementation status of the legal acts, and the evidence base and reporting information together, they allow the Commission to assess the implementation maturity and the effectiveness of the policy against its initial objectives to remediate the negative impact of pressures and drivers on the environment. Now, it gets even more complicated in the sense that in reality, the ecosystems, they don't exist in silos, but they interact with each other. So, for example, we got the food ecosystem, like then we look at agriculture, aquaculture, the energy ecosystem, the mining of coal, wind energy, water energy, and the transport system, private mobility, transports of goods. All these interactions have to be modeled as well, and that is what we call the integrated assessment. For example, integrated assessment that we regularly do is we look at the impact of agriculture on biodiversity. Now, to be able to do these integrated assessments, legislation should be complementary and streamlined so that we have a common definition and meaning of concepts. For example, if we talk about production plants, in some legislation this is called a facility, in other legislation this is called a production installation, and in other legislation plant. So we should try to harmonize on the legal level through legal interoperability these definitions. This would strengthen the impact of the policy because the policies would be complementary and support each other, and would also at the same time, because we use the same definitions and the same concepts, it would also allow to reuse the underlying data in the evidence base for monitoring and reporting, and to assess the the impact we have with our policies. So in the end, this will lead to better regulations, so better lawmaking, and also better policy implementation, and less administrative burden on the member states for providing data to the Commission. Hope that was a bit too fast there. I think this is the one. Okay. So in general, policy development, implementation, and evaluation would greatly benefit from interoperable evidence bases. And these evidence bases should be cross-policy and cross-domain, meaning in a sense, if somebody reports, if a member state or a competent authority reports, for example, a agriculture holding to the Commission, that same agriculture holding should also be able to be used by DG Environment for the impact assessment of agriculture, or for the impact assessment on air pollution when we're talking about chicken farms and so on. So the policy development. So to have the best possible implementation and the best possible use of data, we need to have legal interoperability and semantic interoperability. Now, we don't have many implementations for this. On the legal interoperability, the only thing I'm aware of that we are using is of course the ELI, which is already European legislation which uniquely identifies legal acts, that we can reference in other legislation and implementation text and guidance text. On the semantic interoperability, we do have a directive within DG Environment, which is called the ISA² Directive. That's the Infrastructure for Spatial Information in Europe, which also offers a kind of a set of data models for 34 teams, and to which the ISA core vocabulary is aligned. So these things are already in use, and they do help us a bit. And I think the second use case is based on semantic interoperability based on the ISA² Directive. A bit further on, if we would be able to actually code the legal provisions as core criteria in the CCCEV, that would start to promote legal interoperability, make, as it's a core component, a corporate component. It will also be reusable by other DGs and member states and competent authorities in member states, and would also be able to drive other business processes and business process improvement. A good example there is, of course, which was also already referenced by Enrique, is the procurement process. Just an example of possible artifacts that we could code in the core EU environmental criteria. That we're talking about reporting obligations. What do the member states have to report? This consists of the data structures which have to be used by the member states to organize their data in a comparable way across member states, so the Commission can compare the progress made in the different member states. But also it's a set of criteria. It's a set of emission levels and these things. Also greening criteria, we have a lot of labels. We've got the eco label, eco design, the carbon emission levels, use of materials, and all these criteria which are sitting now in the environmental legislative acts could actually be documented and coded in a core vocabulary and then be used again. Protection measures on how to protect, which are the measures that are elementary to protect birds, to protect habitats of species, to avoid and eradicate invasive alien species, and so on and so on. Now, these kind of definition of criteria on a higher level in a structured way with a common ontology, together with a common ontology for the underlying concepts, which could be an extension of the ISA core vocabulary, towards more environmental spatial objects and feature types, that would allow to streamline similar concepts in different domains, such as the physical features. We have already discussed this, the agriculture holding to be used by DG Environment, also by DG Agri, but we're also looking at species evolution that, for example, fishes in the ocean and the seas, that could be used by DG Mare and DG Environment. We're also looking at land use to be used by DG Klima, DG Environment, DG Mare, and DG Agri. Production facility, and that's another use case that I will present. So we have now a common model for production facility within DG Environment, but that's also reusable in a lot of other contexts as well. the reuse of existing code lists. We have a set of code lists which are now managed by different organizations. It would be very valuable if also these code lists could be documented in a kind of a central corporate component, which is publicly accessible. And this kind of a common ontology, both for criteria and for these feature types that are relevant, call it master data if you want. That could be a fundament also for European data, to build a European data space that not only serves the better policy and the better regulation, but also helps in boosting the European data economy and as a support for digital transition at European level, but also at national, regional, local level. So it has several impacts and several benefits that can be achieved by providing more interoperability. Now, let's go to the use cases. For the first use case, and for this courtesy to Cécile Gouache, who helped me with this one. So the first use case is the green procurement requirements as a reference data set hosted by Open Data Portal. So we already discussed briefly the possible labels. We have the Energy Star label, the Energy label, the Eco label, the Bio label, and so on. So we have a lot of labels. Most of this criteria for these labels are now documented in legislation. So for every criteria, for every type of product, for the Eco label, for example, we have a commission decision. And then we also have a fact sheet with relevant information, but it's not structured and machine readably documented for systems to be used in business processes. Now, if we could code all these legal provisions as core criteria in the CCCEV, then we could support the greening of ICT procurements. And this could also strengthen the other policies we have on circular economy, materials, and mitigate negative impact of our consumption patterns and of the digital transformation on the environment. An example there is we have now about 5 billion cell phones. Everybody has to plug in a cell phone in a plug every day to charge, and this has an immediate impact on the need for energy and directly also on the environment, because more coal has to be mined. There are some wind, there is wind energy and solar energy, but this also has to be structured, and pipes have to be set up, or a network has to be set up, a grid that provides all these consumers with the energy. So this is long stretching impacts on the environment as well. And if I reflect a bit on what Enrique was saying about the e-procurement ontology, I think that would be an excellent place to also include some ontology on environmental criteria, which could be used then, of course, as a selection criteria or even as an awarding criteria. This would be then called the greening of the procurement process. So this is the first, and I also had, thanks to Cécile, she provided me with a business model that she already drafted a while ago that gives us a head start if you would like to actually start implementing this kind of use case. Who are the key partners, what the value proposition would be, customer segments, revenue streams. I think this model already has a lot of information, but could be further completed with some perspective from the environmental aspect as well, and relating to policy. But that's something that we can work on. But I think it's a very valuable use case that is very feasible to implement and would have a direct added value. Second use case is a bit closer to home for me, and that's about the streamlining of reporting. We have already done a big fitness check on environmental monitoring and reporting, following the better regulation initiative from the last Commission. And based on that fitness check, we also had an action plan, and one of the actions was the alignment of different legal acts. So we aligned different legal acts, about 10 legal acts within DG Environment. These were environmental legal acts on three levels. So first, on the timing, we are making sure that we are streamlining the frequency of the reporting, so that we don't have reporting every 6 months, every 3 years, every 6 years, but have a more regular frequency, allowing us to have a regular update of the evidence base. We also try to streamline the process, how member states have to deliver the data to the Commission, and from the old system where member states had to upload files to a file server. We are now moving away, and we're trying to look at the proactive dissemination of data by the member states by providing APIs and services that can be harvested by the Commission in due time, according to the frequency of reporting. A third level of alignment was the content, making sure that we use the same concepts in the different legislation, and that would promote the reuse of semantic interoperability, and of course, as a result, the reuse of the same data in different policy fields, and that would minimize the burden of the member states. And it's all in the principle of only once, use many times. So that was a very important exercise for us, and we did 10 legislations, but let me focus on just one. And then we're talking about the emissions, and we call it the EU registry on the industrial sites. Now, this is as an exercise that merged four legal acts. It's called EPRTR, which is a directive that mandates the production installations and production installation holders to document all their emissions to air, ground, and water in detail. Then we also have a directive on industrial emissions directive, large combustion plants, waste incineration, and coincineration plants. All this was merged in one single model, and that was the semantic interoperability. And there we have used the ISA² directive, which provides all these data models for environmental spatial data objects. We're using that directive to remodel all the information in those four directives in one common model, which we call now the EU registry, and this will become a evidence base of all production facilities or industrial sites in Europe. So it's a very valuable one that can be used by a lot of other initiatives at European level and national level. Reporting obligations there are for 33 countries, so we're covering most of Europe, including the EFTA countries and Serbia. This will become a reference data set. We already had some discussions with Digit on the possible value and the hosting of this kind of data set. But for the moment, this data set will be hosted by the European Environmental Agency. On the legal side, so this is a model that supports, because we have aligned all the legislation, there was the legal interoperability. On the concept side, this implements all the legislation, the thematic top-level legislation, but also uses the ISA² data specifications and the Commission implementing decision on reporting at the same time. So this will release a lot of burden from the member states. Just to give you an example, if you're a chicken farmer in Europe, then you have to report to DG Agri under the Common Agriculture Policy, a lot of information several times a year. At the same time, you also have to report, on the Industrial Emission Directive to DG Environment. On a 2-yearly basis, you had to yearly update your EPRTR catalog with your emission data again, and so on and so on. So you have to report many times the same information. By aggregating all these models, then you already will be leveraging the possibility for the other DGs as well to make use of this evidence base, and to make sure that member states and private organizations have minimal administrative burden. So just to give you a tangible idea of what we're talking about, which kind of features, so it's all spatial as well. So we got all the slide definition, we've got the production facilities, we got the details of the production facilities in the several plant elements or silos that are made available, and then also the chemicals that are available in these detailed elements, and the production processes. So that's a lot of information. It's all put in a common model that takes into account the feature types, but also the data types and the code list. And that could be actually reused as well. Could be reused in an extension of the core vocabularies in the future. So I guess this was it for me. I don't know if you have time for some questions, or if we're going to take the questions together afterwards. But that's it from my side. Thank you very much.